Hey everybody, this is Larry. This is me going Q4 of the bi-weekly contest 132. Find the maximum length of good subsequence 2. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So I have a Q3 video. I'm not gonna repeat that much just because I'm really tired, but also like I think I go over it a little bit. Again, for this video, I assume that you are already reasonably good at dynamic programming, and then this is just like the next step, because I think this is definitely a difficult. Well, Q3 is a difficult dynamic programming, but it is something that I think most people should be able to do with the Q3 constraint, or at least that's what you should aspire to for interviews. And with that, you have to be reasonably good at dynamic programming in general, to be able to do it in a quick time and stuff like that. So that background is necessary because I only have so much time to kind of go over all the basics. So definitely practice dynamic programming. And my apologies if you have to come back later. That's fine, right? Just bookmark this, come back later for the explanation. But yeah, and this is the solution for Q3. Not going to go over it in too much detail, but it's just basically given this index as the last element in the subsequence and how many changes that we get. These are the interactions that we get, right? So we have something like this. Okay, so then the next thing that so this is now the Q4 explanation beginning. So now let's say you already understand Q3, you know how to solve Q3, you know how to look at this code, right? So the first thing I noticed was, I noticed two things, but yeah, I think the one thing that I notice is that we're looking at these max functions, right? What happens? And for this, I am going to bring up some drawing thing. I am traveling right now. I'm in beautiful Columbia, South Carolina, and yeah. So I'm going to draw with my mouse my touchpad. So my apology if this is a little bit whatever. But yeah, but let's just say we have a grid. I'm not going to draw the entire grid because again I'm drawing with my finger. So let's say this one is in my notation. Let's say this is index. Well, maybe I'll go a little bit backwards, right? Okay, fine. This is index delta, right? Oops. I'm just going to go I for index and then triangle for delta, right? So that's the thing that I'll show you my code in a second. And what does this do? This basically gets the max of all these things, which is so if you look at the code, which I don't. All right, I'll show you the code real quick. So if you look at the code, we have two things, right? One is that for all the index nums of index equals to nums of j, we just look at this thing, right? And what is this thing? This is basically the number that is so we're keeping in mind that here we're going from index delta to j delta, right? I guess that's the most important thing. And then here we're going from index delta to j delta plus 1, right? Okay, so here bring back the graph. So we have two things, right? So yeah, we're maximizing two things. One is the delta plus 1 part. So we have to show that this is the let me change the colors real quick. So we have the delta plus 1. Let's say this is the delta plus 1, right? And of course, we assume that delta plus 1 is less than k, but this is the delta plus 1. And we're trying to get the max out of these things, right? These cells. And then there's another thing, which is just index delta to j to delta. So we're trying to max, a function of these things. But this one has a constraint, right? So this one, there's no constraint because we just assume that they'll be different, but there's a second observation I'll make in a sec, right? Delta plus 1, right? And then here though, it's that if if I'm going to call it a sub I, right, as the element, then here we only want to take the max of elements that are the same, right? Meaning, say, maybe the cell also has, let me redraw this a little bit. Let's say, yeah, let's say 3 cells also have the same a sub I, like, for example, if this number is a 3, then a sub j is also 3, right? So here we want to j, sorry, I'm drawing with my fingers, is equal to 3. So then here we just want to take all the we want to pick out the cells where this is true, right? Where all the they're all the 3s, and then we want to take the best answer from all the maxes, right? Yeah, and actually there's another observation here, right, which is that and I didn't do this explicitly, but let's say whatever this answer is, right, this answer is actually always going to be bigger, right, than this answer. The reason is because because they're the same number. Because they're the same number, this transition graph transition to this one, right? So that means that this one can always be bigger than that one, right? So you can now reduce this to just this going to the next cell, because you know that this answer is already the same of all the other ones, and then also throwing out here, right? Throwing out all these other things. And there's actually probably a way to do this. Let me actually take out so that's the general visual idea. I just want people to look at this visually, because that's how I think about it before doing the next step. And I think, like I said, wanted to say, I think you could do this recursively, but for me, it scares me a little bit, so that's not how I did it. So the first thing I do is I convert this to, this is n squared k, right? So this exact code, I converted it to, I didn't write it that way though. Let me because I did the increment thing, which I didn't explain, but yeah, if delta is, let me rewrite this real quick though. Greater than 0, well, delta is always going to be greater than 0. Yeah, so it's either this, or if they're the same, so this is if they're different, right? If they're different, then we do this check. Otherwise, otherwise they're the same, which actually is kind of double negative, so it's a little bit awkward, so I want to do it this way. Otherwise, this is just equal to this, right? And this, of course, for the most part, though, I think this, I don't, it feels awkward to do a +1 and then count backwards. It doesn't matter that much, but that's why I do it this way. Yeah, if they're the same, then we look at here. If they're different, then we want to make sure that this is greater than 0, and then do it that way, and then just do the best over those things. And this is very similar to this thing, right? This idea, going the other direction a little bit on the delta, but that's the same idea. Okay, and then now, as we said, we already broke it down to 2 cases, right? One is if they're the same, and then one if they're not. And then here, well, and in both cases, the idea is to reduce this, because right now we have n squared times k, and the idea is to remove one of the dimensions, right? So that can be only n times k, at least for Q4, right? And that's basically what I did, is that if you look at the drawing, there are only 2 cases. They're the same or they're not. And the idea here is that for here, we're trying to get the max of this section, right? Well, what can we do? This is just a prefix something, right? I mean, I know it's suffix or whatever, but you get the idea. It's the idea of having a rolling max, right? So then here, what we're going to do is that we store like in a rolling kind of way. And you could, there are different ways of implementing it. I don't know that my way is the cleanest, but here you can just say, okay, you store it elsewhere where, okay, the first cell has a max of some number. The second cell is going to be the max number of the first two, and then the third one. And you could do that all at one time because it's just this number, the max of the third number is just the max of the third number and the first two, right? And in like transitive kind of, or not transitive. I don't even know the words anymore. It's too late. But yeah, in like a dynamic prefix sum kind of way, you just do it. You calculate that one thing at a time, like a prefix sum where the sum is max and where the prefix is suffix, and that's basically the idea. And here I'll go over the code with that in mind, right? Some of this is a little bit awkward. I think I should have just maybe done this with. This should be n+1. I think this would make it a lot easier to just skip this part anyway. And I could do right. And then now this part will be just previous of j. I think this is right. Let me double check real quick before we go over it. Apparently not. Wait, what? This is j-1. Yeah. Let me give a quick submit. See, making sure that this works before I go over it. Okay. But basically this is the same code and spirit to this one, right? We remove this thing, and then now we just calculate for each delta and j. First, this is the prefix sum thing that I talked about, right? It's just the prefix max. I do this calculation, and I make sure that this delta -1 is greater than 0. But otherwise, I just take the max of the. So this is a little bit awkward looking, but it's just it takes the max of the previous element or the DP of this element. So that's basically the same idea. It's just a prefix max. And yeah, and here you can see that we use it in this way, which is that we take the prefix of all these things. One thing I would say I actually forgot to point out, let me bring back up the drawing real quick, is that the reason why that we can do it, because one thing that you may say is that, and I kind of missed this, is that, okay, we go here, in these boxes if they're the same element, but does that mean that we cannot use elements here, right? Because they are the same. Why are you maxing over the differences? Well, the reason is just that if you kind of think about it in a strict, like a limit kind of way, like limit as in how many things that we can use as a cap kind of way, then if you think about it in that sense, that means that if you have a choice, if the elements are the same, you have two choices. You can either use it or don't use it. Then, of course, don't use it will always be more optimal, right? Meaning, let's say you have, for example, let's say you have this input, right? You have k is equal to 2. So if you have k is equal to 1 instead, the answer will always be smaller, right? Or the same, maybe, but it's the same or smaller, right? If you think about it that way. So, but as a result, that means that you don't have to, you could probably do some things to handle it, but that means that you don't have to, because you know that the same, which we'll go over in a second, but if you look at, let me bring back the drawing real quick. If you look at this drawing, that means that this number, which I'll do in yellow, and orange. So that means that this number will always be bigger than this number, or the same, right? Greater than or equal to, because and the bottom number means that you have fewer resources to use, right? The delta or whatever, the k. So as a result, this max of just this, it doesn't cost anything, right? Because you know that you like that answer will not change your answer. It's why you can do it. And then the same is that, so here I just keep track of the, I mean, yeah, I just keep track of the same thing, right? So for example, if, yeah, this is basically the thing about just having the same row, right? If you're having the same row, you want to just look at the numbers that are the same and what their values of and the max of that. So that's basically saying, okay, when we go in the correct order, then we can just look at all the numbers that we've seen and then add 1 to it because you're adding the current number because it's the same number. And that's basically the way we have here, right? Is that we have the same, we have, we put in a hash table. And then if the current number appeared previously, yeah, number previously, then we just take the biggest number and then plus 1, right? Because you're adding a subsequence, and that's basically the idea. And we update it to get the max, so it gets the max of this or this, and then we update the same with that number with the current value, which I guess is going to be same plus 1, maybe, or maybe it doesn't, right? But whichever path it takes, it does this number, and that's it. And then you take the max over all of the cells after you're done. I mean, you could probably even do something less funky than that, but why not? And that's it. This is this is a bottoms up thing, so you could see that it's going to be n times k space and n times k time. One more thing while we're doing this, right? You can actually do a space optimization and reduce this to O of n time. Oh, sorry. Just, it's called space optimization, not time optimization. You can reduce this to O of n space. Let me just write it out because I feel like I don't know. So this is n time, O of n times k space. You can optimize this to O of n space, noticing the space optimization trick, which is that, notice that in every one of these, I mean, we don't even use the previous deltas here, so it's unnecessary, right? Or like you see that, like these does not have to be 2-dimensionals, right? Because everything is the same. The only thing that we do use delta of 1 is here, so that means that you can replace this. You can replace this with another 1-dimensional array that you kind of just like free up every time, and that will give you O of n space. So you could definitely do a space optimization here. And yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to your mental health. And yeah, you could watch me solve it live during the contest next. I was thinking too fast about Q4. Well, like I didn't think about it, but I was hoping to go to it. I just said it. Oh, and this is a harder one. What is the? I didn't even remember that. I did notice it, but I forgot about it. So this is not DP then. But is it 50? What's this? 5,000? Okay. So what is this function, right? I'm trying to think whether I can optimize out this function in a way to like a log n operation or something, and that'll make it a little bit Guccier. It's basically so if it's the same, you do not increment. And if it's different, you increment. Okay, how do I think about this? What is the data structure that I want for this? And I even had a silly mistake on it, but that's fine. So I think you could cheat. because by definition, yeah, you could cheat with like a prefix max or something. Because I think by definition, one of them is like like you get to skip it by cheating. Okay, let's okay. Let's explore what I mean here. I guess I should do it on the whatever, but still a little bit annoyed that I got that wrong 5 minutes. Okay, so we have to convert it to top down for now. What am I doing? K plus 1. Right. And then yeah, okay. So then now we want to rewrite it. We want to say it's for if I could type correctly anyway. Yeah, okay. And now something like okay, let's just do it the dumb way of getting it right first, right? So this is equal to oh no, I'm missing an index. That's why I was like, why is this so hard? And also this j is not that j. That's why. What am I doing? This doesn't even make sense. Like, okay, so okay. I usually use ij and k. That's why like I'm just struggling in my mind to come up with another variable. But okay, let's just actually use the same variable name, Larry. So delta in k. Okay, and then now for j in range of x plus 1 and are these the loops that I want to write? I don't know yet, but let's just focus on getting this right first. Is equal to well, just 1, because you always have this one character, right? I guess this could have been just like here. Okay, fine. But then now is, oh, this isn't right. This is equal to max of dp index delta of or dp index j. Nope, Larry. Delta plus increment where plus 1 where in if no, what am I doing? You're doing it in the wrong order. Yeah, okay, you're right. I could do it in this order, but it's just a little bit more awkward. Okay, so when this alright, just keeping it similar for now. Okay. And then now yeah, okay. I'm just verifying in my head. I think this is right. And it's just that it makes the thing a little bit trickier because now I want best 0, 0, and I have to check it here on every index because it can be anywhere. Okay, that's fine. Right, so this is the DP. Am I submitting on? Okay, it is the wrong DP. It's not even. But I should check this on Q3 because then I don't get a fake wrong answer. But what am I doing wrong? What I'm doing wrong is that there are a couple of things. One is that if delta that is doing some funky things. What am I doing wrong? This is wrong. No, these indexes are wrong. That's why. It should be J. Okay. Yeah. But then now I can do this. Okay, so J is equal. Yeah, okay. I think this is right. I mean, I just have to move this here. Is this right, Larry? Is this right, Larry? Okay, let's give it a submit on Q3. If not, I'm a little bit silly. There is some like performance hit, that's why I kind of worry a little bit. But if wait, what? Why do I get 0? Oh, because I put it in here. No, wait, what? Press is 0. Why is this a 1? I put a 1 here. Oh, because these are all 1s, but we don't. But this should. Oh, because this J loop doesn't do anything. I was trying to be clever by moving it up, but I still have to do this thing of. Okay, I removed it and then now I regret it. But luckily that doesn't cost me anything. Okay, good. Because I'm doing it on Q3 and not Q4. Alright, silly mistakes. Let me see how people are doing during this contest. The leaderboard. Okay, so that's good. So we converted it bottoms up. So the key thing, there are a couple of key things to notice, right? Is that index is less than J. So yeah, so the two cases. So we're going to remove the index. And then this is going to be just 0 to n. And the reason why we can is, can we? No. Okay, I mean, I know how to do this, or I have an idea, and we have. I'm dirty dirt, even with the silly mistake. 1 hour and 10 minutes. Okay. Wait, that seems high. I don't think I did it that much. But okay. We could remove one of these dimensions by an observation, which is that. How do I write it exactly? I think I could remove this. Okay, there are only 2 cases. I know how to do this. Come on, Larry, focus. How do you do it correctly though? The 2 cases, the numbers, right? So then now, okay, so let's start with the numbers. How do I do this? Delta, we don't do it delta, we do, I think I want this loop, but it, maybe that makes sense. Can I do it this loop? With the same, yeah, no, you're right, no, that's right. It's just that my indexing is very poor, so it's confusing me. Or my indexing choices, whatever. Okay, so then now on the same delta we have a previous thing, right? So like a prefix array. Not a, yeah, I mean a prefix array. Okay. Okay, I know what I need to do. I think I'm just confusing myself too much with the way that I'm writing it. So I need to go back to here. This is the correct one, right? Just making sure that it still corrects, or is correct. I need to change the index. I think it's messing with me too much. So then now it becomes delta J. I'm not smart enough to not need to change this, and I think that's, I don't know, it's just too confusing for me. I know how to do this. I keep telling myself to, because I feel like I want to be confident about it. Okay, still good. Let's give it submit, because it's a free submit, so let's give it submit. This is still Q3 submission on the same problem, right? Judging. Right, I mean, it should be okay. Okay. So then now, if we get rid of this, what are we getting rid of? We're saying that, okay. So let's say we have 2 cases. One is the same, right? So same is you go to a lookup thing, right? So then here if same, and oh, this is just n, if nums of j is in same, then dp delta j is equal to min or max, whoops, dp delta j, dp, it's going to be same of nums j plus 1. Yeah, okay. I have to update that. Okay, remember to update same. So same sub nums j is equal to dp delta j. Okay, maybe. And then, okay, so that's for the handling the same, which is the prefix where increment is 0, right? So then now we could just go to here. Is it still right? No, because we have to do the... And then now we can just... Wait, what? Oh, no, we moved this, so then increment, so all right, I deleted too much. Okay, so then now it's just this thing. And we do this for all index, so then we need a prefix for it. Right, all right, let me just run it real quick. Does that work? No, because we have index, so it doesn't work. What we need is a prefix thing. I thought about doing it too clever, so I'm not going to. So I'm just going to do something like whatever. Is that right? No, I think I have an extra index for no reason. I think that's why. Yeah. And now you have prefix of j is equal to dp delta j, and then if j is greater than 0, something like this, I want to say. And then now this becomes it's either j or j minus 1, maybe. Should be minus 1. Should be minus 1. I don't think that makes sense otherwise. Okay. Oh, I did delete increment. Okay, that's the wrong answer, but I like your spirit. Oh, no, this is not delta. This is delta minus 1. Whoops. That's why it's... I mean, I don't know if that's why, but... Alright, that's just way funky. But that's all... Actually, that's because delta could be 0, so it's doing some crazy things, maybe? I don't know. This is also weird. Maybe I should have done a... This should be an n plus 1 array. I think that's why. But in any case, maybe that's good now. If statement block, what? Where am I looking at? Line 14. Oh. Yeah, okay, fine. I don't know if this is what. Okay, 421 again. Was this supposed to be a 1? This is supposed to be a 1, right? Let's give it a submit. YOLO submit. Alright. Let's put it here. Alright. This is a tricky one, but I don't know if I was confident about it, but I saw the direction. Yes. Alright. Half an hour or so. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, this contest, explanation, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.